recording as well. So, okay, goody good. Warm welcome to this workshop, originally designed for the PhD by practice students, but I've taken some liberty and invited some of my interested colleagues as well. I can see all those here. So thank you very much for joining, and also my own PhD research students as well, they are here. So this workshop is about qualitative comparative analysis, and it's an emerging method, and increasingly some of the leading journals in the management and entrepreneurship space, and also IS space, they are suggesting its use as potentially revealing more additional research insights. So that's the whole purpose of this workshop. And so Inoke is saying that no sound is coming, but probably she needs to check her system, because rest of you can hear me, right? Yep. Thanks, Shamila. Thank you very much. Yep. Should be fine. Yep. Thanks, Karam. Thank you. Welcome, Karam. Thanks. Thank you very much. Okay. Before I formally start this workshop, quickly speaking, right? We've got 22, 23 people here. So we've got a very ambitious plan here. So hopefully, when you finish this workshop, you would be able to not only conduct, do the operational thing, to be able to, run a qualitative comparative analysis, but you would also try to learn something that can inform the designing of your research that is more appropriate for a QCA-based study. That's our objective, ambitious objective, but at least we can make a start, and then we can follow up with some additional resources and get to find out more about this thing. Okay, I will go forward, and before anything, I have to acknowledge this country. So we respectfully acknowledge the Wurundjeri people of the Kulin Nation, who are the traditional owners of the land on which Swinburne's Australian campuses are located in Melbourne's east and outer east, and pay our respect to their elders past, present, and emerging. And we also respectfully acknowledge Swinburne's Aboriginal and Torres Strait Islander staff, students, alumni, partners, and visitors. So after this acknowledgement of country, I'll go and talk about the agenda for today's workshop. 3 broad steps. Many of you probably wouldn't have got that experience of QCA first step. So it's important that we first cover the introduction and the overview. And once we do that, then we'll go to the workshop style. So we'll do an illustrative example. We'll take an research problem, and we'll perform FSQCA or QCA here in this workshop. I'll first guide you on the steps. There are 4 steps here. And once I provide you that guidance, then you would be divided into the breakout sessions, and then you would be given opportunity to repeat the same set of steps so that you are able to run the software yourself. And once we do that, so getting the background necessary pre-work that's required to actually make sense of the second set, that I call as nuts and bolts of FSQCA. And once we go to that point, perform a QCA study ourselves, just a small version of that. Then the third one is actually putting it all together. So you would be able to see when you complete step 2 that running an FSQCA analysis is not that hard. But the more important thing is that how can we put everything together? So designing a QCA study, configurational theorizing, this is a new word that I'll describe briefly after some time now. And then how can we apply it to quantitative research? How can we apply it to qualitative research? The best practices, some useful resources. And one of the objectives of this workshop is to build a community of practice here so that we can continue learning from each other. Because I've taken many years to come to this point where I can talk about this thing. But the rest of us shouldn't take that long. We should learn from each other, and we should have a community of practice. That's the whole objective. When we finish, there'll be an opportunity to join that as well. So with this, I think we're good to start our first thing, introduction and overview. You're more than welcome to stop me anytime if you want any clarification. So it will help to have this, to keep it as a more of a dialogue than monologue, because we are running a workshop. But specifically after the end of each section, section 1, we'll have dedicated time for Q&A. Yes, Andrews. Yes, I'll share it. Right. I'll share the slides. Yeah, I'll share the slides. I've got plenty of things to share. So when we go to that point, I'll tell you how and when I'll share the workshop resources. So number 1, you can stop me at any time if you've got any question. You can talk, you can raise hand, you can talk, you can type, whatever you feel comfortable with. But after the end of each section, like section 1, we'll have dedicated time for Q&A section as well. And the section 2 is more of a breakout session, so a lot of interaction, and section 3 as well. So we'll have opportunity to stop me whenever you want. Now let's go forward. Let's start the introduction and overview. Now I've taken an example just to break the ice and to explain the philosophy of QCA here. So I've taken a very a thing that we all have experienced here in Melbourne for the last good 250 days now. I'm not approaching more than 200 days now. So we have been in lockdowns for more than 200 days, pandemic response. Why? Because they wanted to reduce the social mobility. And these points that I've taken, these are what they call as the directives from the Chief Health Officer. So what he's been advising the government, that everybody should work from home, as we all are doing now. Stay at home. There's a 5K travel limit. We cannot go beyond that. Schools are closed. Retail outlets are closed, except for essential groceries. Gyms are closed. Swimming and indoor sports closed. Outdoors children play grounds closed as well. There's a night curfew as well. Now, what's the objective here? The objective here is to, as they call it, actively suppress or eliminate COVID-19. That's the objective. Now, having lived through a similar exercise last year, the lockdowns last year and this year as well. But last year we were fortunate that we were able to eliminate COVID from our society. So from last year, what if at all we take it as a research project? So we want to learn what happened last year, and these were the set of measures that were taken by the Victorian government, 3, 6, 8 set of steps, right? Health advice. And in a hypothetical scenario, if we were to examine this as a formal research project, that what were these? So how were these 8 explanatory factors were able to or their contribution to the elimination of COVID last year, if we take it as a research project. So how are we going to start? The first thing that we'll do is, right, what we've done is we have already done some work. We've identified what we call as, there's been some confusion. Some of the students are joining the workshop on MS Teams. I don't know why is that, because this was clearly mentioned and I put a message in there as well. So I hope I'll just take 1 second and drop a message to her. Oh gosh. I'll be back here. Sorry for the disturbance here. So as most of us, or probably all of us, are business school researchers, so generally we research what we call as Yeah. Then there was probably another one sent that was talking about the this workshop being conducted in Collaborate Ultra. So there were two actually. Yes. So yeah. So yeah, that's the confusion probably. Okay. So how do how do we start, or how do we conduct research on this thing, right? As we all know in management and business, we've got two types of research: is qualitative and quantitative research. So qualitative research has certain advantages. It gives more holistic causality explanation. It's case-based, small number size, small size, high level of detail, interpretive. Whereas the quantitative research is, linearity is the assumption, variable based, pattern recognition. Now, because I've already done some work, I've already identified some of the explanatory factors and then the outcome of interest. So it's more leaning towards what we call as quantitative research. So next step would be from here on is to identify, the relationship of these explanatory factors to the, effective pandemic response measured by elimination of COVID-19 cases from Victoria. We'll sort of measure these things through some objective, we operationalize those through some measures, quantify them, and then establish linear relationship, right? So, and through statistics, significant relation, non-significant relation. But if I ask you, right, and anybody actually, so what are the potential problems by taking this approach? Is like, if I take this thing, quantify it, establish relationship, we call that as correlation between the inputs and the outcome of interest. The main issues that are here, for example, and we experienced that last year too, some of the people were saying that night curfew simply has no relationship with the COVID-19 effective response, and there was a court case as well. However, even now there's a night curfew, right? So why is that? Why night curfew is still in force? And if you want to see from the chief health officer's perspective, he would have, and they have been very clear in stating this thing, is that some of these things may be directly related to the effective control of COVID-19 outbreaks, but some of these factors are actually indirectly contributing to the enforcement of other measures. The Premier has been saying this thing. So when night curfew combines with other of these explanatory factors, then it may have a relationship with the effective or the outcome of interest here. The point I'm driving towards here is that there is causality, phenomena of causality, which we call as I-ness, so insufficient but non-redundant parts of unnecessary but sufficient conditions. Mouthful, I get that. I'll explain those a bit later. But at this stage, I-ness causality is when an individual causal condition or individual explanatory factor is not necessary or sufficient to cause an outcome, but when it combines with other explanatory factors, it would have a significant bearing on the outcome of interest. So for example here, night curfew may not be on its own linked to the outcome of interest here, but when it combines with all other explanatory variables or any other explanatory vectors, it becomes significant. That is what we call as I-ness causation. Another thing, and we call this as another origin of QCA is from the work of Reagan in the 80s and 90s, and he titled his work as Reimagining Social Inquiry. How can we conduct these social inquiries differently? And then he came with this idea that instead of this correlation based, we should be focusing on necessary and sufficiency causation, that some conditions are necessary to cause an outcome and some but still not sufficient, and then there are conditions or there are some explanatory factors that are sufficient to cause an outcome. So those sort of causality which led to a parallel domain of QCA that is some people suggests that provides additional insight. So giving this example and then extending it to the literature that we are more familiar with is what we call as management and organization research. Similar to the social inquiry that I initiated in the previous slide, the health, the public health inquiry, how was the COVID-19 outbreak controlled? So there were many factors, and then many factors combined to cause an outcome. That outcome was elimination of COVID-19. So here we're bringing it to the realm of management and organization. An organization is a multi-dimensional constellation of interdependent elements that commonly occur together. The same thing, multiple factors, multiple explanatory factors, or here in this case, interdependent elements combine together to cause an outcome. So based on this, so this leads to a particular type of causality that's central to the QCA methodology or QCA thinking. We call that as complex causality. So complex causality is that causality where multiple explanatory factors or multiple causes come together and cause an outcome. And that complex causality is described by three distinctive features. The first feature is that outcomes really have a single cause. Multiple things come together, very similar to the COVID-19 example that I gave you earlier. If I ask you to pinpoint one factor that allowed us to eliminate COVID-19 last year, probably it's a combination of all factors. That's what most social phenomena are. Multiple things come together to produce an outcome. So this is what we call as conjunction. So multiple explanatory factors have to combine to produce an outcome. The second one is what we call as equifinality, that there is no one pathway, or there is no single pathway to an outcome. Things combine in a way that there are multiple pathways toward the same objective. That's what we call as equifinality. And the third one is asymmetry. Central to statistics is the more the input, the more the output. And that implies the less the input, the less the output. So statistical based modeling and analysis inherently assumes symmetry, causal symmetry, where it may not be the case. In many scenarios, if there is more of an input and of course there is more of an output, but the less of an input may not mean that the output would also be reduced. This is what we call as causal asymmetry. So most of the social phenomena that we see around us, including the management and organization research, these phenomena entail complex causality, and complex causality has three characteristics called conjunction, equifinality, and asymmetry. The take here is that the traditional methods are not well equipped to deal with conjunction, equifinality, and asymmetry in one go. That's what brought the focus on QCA, because it's built on these three assumptions. It explicitly takes into account and comes up with a research study that explicitly identifies conjunction based on conjunctions, takes care of equifinality, and also has an asymmetry part of asymmetrical analysis as part of its QCA working. So let me give you an example, one more example here. So as I mentioned, the take here is that the traditional methods have some shortcomings, that they cannot simultaneously address conjunction, asymmetry, and equifinality. What you see here is, we've taken an example, and that's one of my current research projects, is that on one side, I'm trying to explain regression, which is simply that, in this case, there are 4 input conditions or 4 explanatory variables. They come together and they cause a work outcome on your left, which you see here. So A contributes to work outcome, B contributes to work outcome, C contributes to work outcome, D contributes to work outcome. These four explicit links. That's what we call as regression analysis. We can do thing and then we'll have a result. A would be significant or not significant, B would be significant or not significant. Based on that, we'll have our findings and our contributions. On the other side, what we see is an FSQCA study. Now, first thing is that FSQCA does is that it identifies all possible combinations. Remember the conjunction thing? All conditions or all input variables or all explanatory variables, FSQCA focuses on, examines all of their combinations. So here, because we got 4 input conditions, 2 raised to power 4, we got 16 possible combinations, which I have plotted here for you. A, just one condition, AB, 2 conditions together, ABD, 3 conditions together, AD, another. So there will be 16 possible configurations. QCA explicitly considers those and evaluates their plausibility to cause an outcome here, either towards successful work outcome or unsuccessful work outcome. So conjunction we now know is now being explicitly identified and considered as part of formal analysis through all the 16 combinations. The next thing is equifinality. Now, when we do analysis, we'll be able to see that some of these combinations would also contribute to successful work outcome. There will also be some other combinations that will be somewhat different to another set of combinations, but still contributing to successful work outcome. So that's what we call as equifinality. And the third one that we've got here is, remember, asymmetry. When we do FSQCA, we generally run 2 analyses. Take the same conditions, examining their effects to a higher performance, like successful work outcomes, the positive work outcomes. We also examine their effects for the lower performance or the negation of the successful work outcomes, the negative of what is now successful work outcome. So this in the same study, considering that, identifying that it's the causal asymmetry and running 2 separate analyses, A for high performance, B for low performance, that also explicitly takes into account what we call as asymmetrical analysis. So in this example, I've shown you how a regression model is now better explained through FSQCA model by identifying conjunction, combinations, B, equifinality, and C is the asymmetry. Now, some of you, and I could see very distinguished scholars also in audience here, and they would be able to appreciate this thing. Yes, regression has some elements. We can make interactions. We can introduce some interactions, but those would be limited in number. Whereas FSQCA would consider all possible interactions. So FSQCA is interaction based. So that's more explicitly, it's better equipped to examine interactions, because its central tenet, or its tenet is that all the relationships are interaction based, conjunctions based. So with this example, let's quickly summarize what we have achieved in these few minutes. So what we've achieved is so I've got a question from Sivalai. Let me read this one. How can you evaluate which combination is superior to predicting an outcome? We'll find out. There are measures, Sivalai. There are measures. So when we'll run the analysis, and actually our analysis objective is to identify which combination is more superior. We'll throw some combinations away because we'll say, okay, based on certain measures, they do not contribute to the outcome. And we will have some thresholds. We'll talk about that civil when we'll be actually going through the nuts and bolts of QCA. Okay, civil is it? We'll talk about those in detail then. At this stage, we're just setting the stage, explaining the why should we do it. That's the first question. Okay, Siv? So silence means that I can go ahead, right? Thanks, Siv. Thank you very much. So summarizing. Yes, that's it, Sanga. Thank you for alerting me to this one. Okay, so let's quickly summarize what we have achieved so far and what we have message has been so far, that social phenomena, real world phenomena are complex, characterized by complex causality, or configuration theorizing is what we call as complex causality based theorizing. And QCA explicitly addresses that because it's fully interactions based. And instead of traditional, correlation based, it focuses on necessity and sufficient condition analysis. And at the heart of it is what we call as INES, insufficient but non-redundant parts of unnecessary but sufficient condition. Mouthful, but in simple terms, it says that a condition or an input variable may be statistically insignificant or may be insignificant, but when it combines with other inputs, it becomes significant in statistics or sufficient in the lingo of QCA. That's what INES causation is, and there's a formal definition, and you could go. But INES causation is an exclusive domain of QCA, as in a way, because it considers all possible interactions. So no interaction is left out of the research analysis part. So that's what it is. It is really strong. Now, recently, I'm reviewing another paper which actually brings forward another important, very, very important benefit of going the pathway of QCA. Because all of us, and many of you could see many of you are here, my colleagues here, when there's a mediation or direct relationship is insignificant in traditional correlation-based quantitative analysis like SEM and regression. So we have to come up with an argument just to explain why this is an insignificant relationship. More often than not, we say, look, there was an intermediate stage or there was a lack of mediating mechanism. That's why this is the case. And we talk in terms of mediating. So we do not give an argument, generally speaking, in terms of interaction, which is actually missing the INES causation viewpoint. So INES causation is interaction based, whereas we give the explanation in terms of mediation. So going QCA path actually takes us or gives us a broader perspective than just focusing on missing an element between X and Y, a mediating variable over there. So that's another advantage of configurational theorizing or QCA or causal complexity perspective. So this takes us to identifying that there is another research perspective or research direction apart from the traditional qualitative, traditional quantitative. There is something that can bring together both of these scenarios or these research approaches, which we call as QCA. And you would be able to see Reagan's 2009 book. He's actually calling it redesigning social inquiry, because his emphasis is that without the complex causality taken exclusively in QCA analysis or as configurational theorizing, we are missing an important chunk of the underlying mechanism. So complex causality, case-based and comparative, so variable-based. So the QCA that we've got nowadays started with an extension of qualitative research, quantifying what our qualitative data has to offer, and then making some insights on that. So traditionally case-based, but it's now also in terms of differences in degrees as well. So differences in degrees have also been identified as part of QCA, and increasingly, though it started with medium, but increasingly being used with large data sets as well. Why? Because the hypotheses that we can test through this QCA are much more granular, they're much more specific, and they provide much richer information. So you would be able to see that it's right in the middle. It's bringing the richer insights from the qualitative research, but it's bringing the objectification and generalizability of the quantitative research as well. So it's getting a very strong push. A quick test, all of you, I would invite you to do that. I wanted to do that, but I couldn't. You just go and search the papers that have been published using FSQCA or QCA in the last, go and do a search in Scopus, and you would be surprised to see by the number of the late surge towards move towards this type of research analysis, research approach. Okay, now bringing everything together. So as I mentioned, Reagan started this push from his seminal work in 1987, then 2000, and then this book that I have based my presentation mainly from this book of Reagan in 2009. So it's QCA. So far what I've been doing is I've been talking about causal complexity. That's I've explained as the justification for going the QCA pathway, and QCA is Qualitative Comparative Analysis. To me, QCA is more of an implementation thing. But as management scholars, as management researchers, we need to theorize first, or do the front end first, and then implement that, or come up with a research design and then implement it through QCA. So QCA is more on the implementation side. The front end that should explicitly hypothesize or problematize your research in terms of configurations, in terms of causal complexity, we call that as configuration theorizing. So you start or you design your research in terms of your configurations, and then we implement that QCA. So that's the subtle difference between QCA and configuration theorizing. So configuration theorizing is more at the start, the front end, why you're doing this thing, and then you implement that through QCA. But from here onwards, after explaining this, difference between, or the difference that I think is between configuration theorizing and QCA, we may be using them interchangeably. So don't be confused. The fine difference is configuration theorizing explicitly design or problematize your research in terms of configurations, while QCA actually finishes it off, does the analysis for you. It uses set theories instead of the traditional correlation-based necessary and sufficient condition. And again, I'm just repeating here just to sink in this three unique phrases: conjectural, causation, combination, multiple factors contributing to an outcome. Equifinality is simply that multiple configurations or different pathways to the same objective. That's what social issues are, social phenomena are. And lastly is the causal asymmetry. So configurational theorizing and QCA enables researcher to explicitly analyze a social phenomenon in light of these three characteristics of conjectural causation, equifinality, and asymmetry. Okay, now all of us have learned about set theory, and it's not difficult. Trust me, it's so easy. But how does it apply to QCA? Just a refresher. Set theory as applied to QCA. So all the explanatory factors or input variables or causal conditions that would cause an outcome, they in QCA, an explanatory factor or causal condition is a set. Sets, that's causal conditions / explanatory factors, combine in configurations, the INS configurations, to produce outcomes. So multiple sets or multiple explanatory factors combine together. So now we are equating explanatory factors, causal condition with sets. That's what we call as set theory. Cases have membership in sets, so each case would have a membership in different sets. The degree of membership is also something that we'll talk about later. Also, there is some Boolean logic that the QCA relies on. So logical AND, so intersection of set, multiplication, logical OR, union of sets, logical NOT, negation of sets. Put simply, so A and it's hyphen, right? So it's hyphen A hyphen is 1 minus A. So negation is simply 1 minus what the set values are. So basic, probably we learned that in our schools. That's what we need. And the good thing is, just appreciating these Boolean logics, the software does most things for us. So we really do not have to learn or refresh our deep or more deeper understanding of Boolean logic. Now, also, you would have heard me so far saying QCA, FSQCA. So time has come to become more specific here. So QCA is Qualitative Comparative Analysis. Now we all know. It has two variants, two main variants. One is called Chris said QCA or CSQCA, which is we just assign two, it's a dichotomous membership, either in or either out. Whether you're in the set, whether you are a non-member. Non-membership is 0, membership is 1. Example, a country has a United Nations membership, or a country does not have a UN membership. So in those scenarios where we can dichotomize a set, it's absolutely fine using CSQCA. But now, as you would have guessed, most phenomena around us, they are fuzzy. They cannot be dichotomized, right? So there is a degree of membership. For example, how democratized a country is. So that's a degree of membership. And most of us in management and organization research, we do Likert scale research. So a Likert scale research is 1 to 5, 1 to 7, 1 to 3 is actually it's differences in degree. That's what Likert membership does, right? So Likert scales, FSQCA is for Likert scale membership. It provides additional, it extends the CSQCA to appreciate the differences in degree, which is central to any social phenomena. So from now onwards, if you say QCA, and for this workshop, we are actually saying FSQCA, because FSQCA brings together everything, and that's what is closer to what we do in business research. So we'll be talking about FSQCA from here onwards. So degree of democratization of a country and Likert scale research is all about differences in degree. Okay, now it's an example of the variance of QCA. So Chris said 1, 0, and we now know that some situations may be suitable for that, but most situations would be either 3 set, 4 set, 6 set, a continuous fuzzy set. So fuzzy is what corresponds to the social inquiries in a more fitting manner. It fits better the social inquiries. Now, the last topic of the first part of this presentation is about the types of projects suitable for QCA. So the configurations can also be thought of as causal recipes. Different input conditions combine in particular ways to produce an outcome. So whenever you want to uncover causal recipes or configurations leading to specific outcomes, FSQCA or QCA is our go-to domain because of its focus on causal complexity. Nowadays, the most common use of FSQCA and all the recent editorials or recent papers calling for the use of FSQCA are actually suggesting this thing. So they want, or they think that there is potential to have more deeper examination of hypothesis building and testing. Instead of simpler X leads to Y, the hypothesis should actually be based on causal complexity. So to unearth or to confirm the more nuanced or more complex ways through which input variables or causal conditions would combine to produce an outcome. So that's what the thrust of research is towards, leading to this type of hypothesis testing that is based on Inus causation. Broadly speaking, so it talks about complementarity and substitution effects. Like some of the input conditions, because of Inus causation, together they would complement and would produce a stronger outcome. That's what complementarity is. And substitution effects is that some of the inputs would replace each other. So it's mutual replacement, that's substitution. Complementarity as mutual enhancement, and they would produce an outcome. And how do we do that? That's conjectural, equifinal, and asymmetrical analysis. That's what deeper insights, uncovering of causal recipes. Also, and the original, and it lends very naturally to typologies and taxonomies. So this is something that, typologies and taxonomies in the 80s and earlier part of modern scholarship was that there was thirst towards those things, typologies and taxonomies, but for the last few years there was a bit of a lull in this domain, and probably that's why QCA was lost in somewhere as well. But typologies and taxonomies, FIST Academy of Management 2011 paper, that it developed a typology, and then recently Journal of Business Venturing, the Douglas paper that used QCA to come up with a taxonomy as well. So typologies and taxonomies is a natural, has a natural alignment with how FSQCA output is generated. And it's equally applicable to both qualitative and quantitative research designs, right? Started with qualitative, you quantify and then you generate additional insights, you objectify your qualitative findings, but increasingly and probably disproportionately, the implementation of FSQCA has been in recent times on the quantitative research designs because of the Inus causation and the fine-grained hypothesis formulation and testing as well. Okay, with this I conclude part one, and I need to take a breather as well. Any questions we've got, and any feedback that you want to give anybody, and then we'll move to the second part of our presentation. Yes, David, you're right. You are right. You're right. And this fine distinction that you mentioned, typology is theory-driven and taxonomy is empirical-driven. Absolutely, that's what the general consensus is. And FIST actually develops a typology because they developed a typology based on certain past theoretical work. And Douglas actually just comes up with a taxonomy. So you're right, absolutely, David. Spot on. And the final distinction, probably please go through FIST and Douglas, and they'll confirm what you just mentioned. Okay, good. And yeah, I think there seems to be, yep. Anybody would want to answer this one? What's the difference between clustering and taxonomy? Probably Tuan, you would want to help us here, or no? Or David? Yep. Yeah, clustering is, yeah, both of them are for grouping, categorization. What are the specific differences? I think taxonomy maybe bit of hierarchies in taxonomy, whereas clustering is simple categorization. Something, David or civilized. So in taxonomy, you may have some like hierarchy, like different more relationships, whereas clustering is simple categorization into categories. This is what comes to my mind at the moment. Yes, from the theory may not be, but maybe we have this discussion elsewhere, David, because we've got lots of PhD students here, right? So with Sev and you, and maybe we can have a bit of a coffee somewhere later on and talk about what are the differences between, and also taxonomy and yeah, good. No, good discussion gets us going. Good, lovely. Okay, let's go further and go to the real stuff, nuts and bolts of FSQCA. Thanks, Chef. Thank you very much, and thank you for making it interactive. Right? Yeah. Otherwise, it's too much of a one-way traffic. Okay, so let's go to the nuts and bolts of FSQCA implementing QCA. What I've done here, I have listed 5 broad steps here, and the first step is like common to all quantitative studies. Is that you first, you've got a phenomena like, work from home and other things, and then you have to measure that, right? You have to objectively measure that. So you operationalize that. So you operationalize that through some appropriate measures, and that's common to all quantitative studies, right? Then we go to the calibration stage. So calibration stage is exclusive to FSQCA, and we can call it as a measurement, equivalent of measuring in a quantitative study, but it has some differences. So calibration of conditions and outcomes, most important step that has to be done. Then there's step C called defining the property space or building a truth table. Good point, John. Thank you very much. I think it's a good point. Very good point. Thanks. Okay. Defining the property space, and then after we have defined the property space, we've got this necessary and sufficient condition analysis. We'll use software. We'll use a free software, FSQCA, to actually do these things. And after we've done the necessary and sufficient condition analysis, the last one is what we call as generating and interpreting results. And you would see now quickly that actually FSQCA gives us 3 types of results: complex, parsimonious, and intermediate. So all these 3 results, we need to interpret that. That's a skill. We'll make a start towards that in today's lecture or today's workshop. So measures operationalization, we'll skip. We'll skip because it's common to any quantitative research, right? Calibration of conditions and outcomes, that is a very, it's a very important topic. But for the illustrative example that we'll do, the data would already be calibrated. So effectively, 3 steps we'll do for our hands-on using software. We'll take calibrated data, then we'll construct truth table, or we'll define the property space. We define the property space with the help of a truth table, and then we'll perform necessary and sufficient condition analysis, and then we'll generate results. So that's what we'll do in this part of our workshop. So it's not that calibration, it's a whole topic in itself, and it's a very contested topic as well, because it determines the type of outputs you would produce. So we'll talk about that. We'll talk about calibration. We'll talk about its best practices. But for the sake of simplicity, the purpose of this this breakout session that we'll conduct shortly is that you are able to access the software and run the software and perform simple analysis. So calibration is as an advanced topic, and we'll introduce that topic to you, and we would we'll talk about that, but we'll not implement that in this in a hands-on way in this talk. Okay. So measures operationalization, as I mentioned, depends upon the research design, qualitative, quantitative. For a survey-based research, there is no difference between how we measure a theoretical construct in regression or in FSQCA. At this stage, same. If you're doing, so you've conducted your data as a survey-based study. So at this stage, you just, okay, we're measuring through this Likert scale. That's it. And we should actually have the same test for SCM, regression, or FSQCA survey-based study. The analysis would change with SCM, regression, or FSQCA, but the operationalization, the data collection adequacy, the construct reliability, and the validity test would remain the same. That's what is our, that's what would be the case. Calibration is very, very important and exclusive to QCA, formally defining the process of determining cases membership in the sets representing the outcome and conditions, what we call as the differences in degree, like the Likert scale. The best practices are half conceptual, half empirical process of identifying thresholds that meaningfully represent differences in kind and differences in degree. That's the advice here, but the half conceptual and half empirical process of identifying has also gives some freedom to the researchers, because they can align a measurement or calibration to their research design in a more effective way. But then it can become tricky to convince your reviewers or your audience that why did you do this thing? Why not fully empirical? Why not a rule of thumb? So it's a loose thing, intentionally kept to facilitate a deeper examination as per the research requirements, but then it attracts some criticism as well. A bit of a sticky point in the QCA community. There are different approaches to this one. We'll talk about that when we'll go to the best practices. But it's a very important, that's the starting point of a QCA process. You know, you calibrate all the conditions and outcomes on a scale from 0 to 1. And essentially, we identify the thresholds for full membership, the thresholds for full non-membership, and the crossover point. That's what fuzzy calibration process entails. So I'll give you two examples here. One is the study that I recently did. And so we've got this descriptive statistics, and then there are different scales, ordinal scales, nominal scales. It was secondary data. And then each of this data had some mean, standard deviation, min, max, median. So that was simply the descriptive statistics. And then we calibrated. Remember, calibration entails establishing thresholds for 3 points: full non-membership, full membership, crossover point. So I followed, and I've given explanation for that in my paper as well, is the median approach was that I opted for the crossover point. And then for return on asset was our dependent variable, and we used, I think from my memory is 25th percentile and 75th percentile. The key thing here is you should be transparent. Whatever you've done, be transparent, because half conceptual. So you have to explain what you need to do here. And also explain that you have resorted to substantive knowledge. There are some strong basis to opt for that thing. It shouldn't be random. That's what, so 25 to 75th, so most studies, even FIS 2011 that I mentioned, has actually opted this pathway of having this 25th and 75th percentile as non-membership and full membership category. So you need to resort to what has been, or what generally people have been doing, some substantive basis of using these phenomena or these values. That's one example of calibration. Another example based on Likert scale, FIS 2011 did that. So full membership 5. That's fine. That's fine. Thank you very much. I hope to make a recording, and if you want it, we can make it available. Thank you. So there's a 5-point Likert scale, full membership at 5. Full non-membership at 1, and crossover point at 3. That's the middle. So it's for 5-point Likert scale. That's one way to classify or to calibrate your input conditions. Now, as I mentioned to you, the illustrative example that we'll be doing, it will be based on an example that already has calibrated the data. So we'll skip the point A and B, and then we'll do point C, D, and E, doing through a software. But before we could do that, I will explain I didn't use dummy variables, so it's different to statistics sieve. So you saw that I used nominal data, 3-point nominal data. I didn't use so calibration is different. So you'll have to park your statistical background for a moment. But it's good, those who've got that background, they can fully appreciate and make use of this different way of calibration. Good, thanks. Okay. So as I mentioned, this example is Reagan 2009. We are not doing measures operationalization because that has been done. We are not doing calibration, has been done. What we'll do is do step C, D, and E so that you can repeat that in this workshop. So the study sample is 18 countries. So the research question here is, what factors lead to the survival of democracies faced with economic and political upheavals? That was the research question. And they took data from 18 countries. So that was our study sample. So outcome of interest, now we know, is survival. What democracies survived? Survived becomes our output or dependent variable, as we now know. Negation of survival, because remember we have to do asymmetrical analysis. So asymmetrical analysis is performed. Our outcome of interest is survival, then we get its negated value. So its negation would be the inverse, would be breakdown. So survival is good, but breakdown, the country actually broke down because of these economic and political upheavals. So as I mentioned in one of the earlier slides, FSQCA explicitly analyzes all explanatory variables, all causal conditions for a high performance and then for low performance as well. So high performance in this case is survival, which we get from the research question, and low performance is what we call as the negation of a survival, simply getting the logical knot from one of the earlier slides and get that a new variable called, or new outcome called breakdown. So survived high, breakdown low. And causal conditions, this research has already identified 1, 2, 3, 4, and 5 causal conditions. Developed countries, the countries who were developed, were urbanized, industrialized, literate, and stable. So they identified these as possible 5 causal conditions that would affect survival or breakdown, right? That's what they wanted to identify. As I mentioned, steps A and B for this exercise have already been done, operationalization and calibration. We don't have to worry how are we going to measure the developed countries. We don't have to worry how we have to measure urbanized. That has been done, also calibrated. We'll do C, D, E in the next few minutes. So see this table 5.2 that I've taken from this book actually describes what I have just mentioned to you. Survived, they have already measured it. These are the 18 countries, Austria and United Kingdom, all European countries. Survived is an outcome that has already been measured and has already been calibrated. So this scale has been calibrated through some measure from 0 to 1. So United Kingdom has survived, so 0.95 means high survival. Then all the 5 input causal conditions: developed, urban, literate, industrial, unstable, or stable. So they were measured like this, they have been calibrated. Urban measured like this has been already calibrated between 0 to 1. Literate already measured has already been calibrated. Industrial has already been measured, is being calibrated. So unstable has been measured, and now they reverse it just to get this done, and now they have done as stable as calibrated. So all have been calibrated, and we'll take these calibrated values to perform a QC analysis. No, Shiv, it's not like it's there are some differences here. There are some differences here. You could do standardized, that could be one calibration, but the substantive knowledge in the QCA field opts for different ways of calibration. That's one way of calibration, but that's not the mainstream way of calibration in the QCA literature. Okay. So that's the calibrated data that we've got, that I've taken from the previous table. This data is an CSV file that you would use to run FSQCA software to obtain results in breakout sessions. That's what we'll use. Developed, urban, literate, industrial, stable, these 5 conditions affecting the survived outcome. Yes. Yes. So it's between 0 to 1. So its calibration is between 0 to 1. Okay. Now, before you actually go and do it yourself, I have to guide you a little bit so that you can start doing this thing. That's our input file that will run in the software, and we'll get the results. Okay. As I mentioned earlier, the first step in defining the property space is to construct a truth table. It's actually generating a truth table with all possible configurations or all possible combinations, so that we can simply find out 2 raised to power 5 would give us the all possible configurations. So the 5 input causal condition in this case would result in 32 configurations or 32 combinations. However, you could go and still run it like that, but I wanted to give you a bit more detailed insights on how these configurations are generated. For that, what I've done is, for simplicity purposes, I've taken just 3 conditions, because 2 raised to power 3 is 8. So 8 conditions or 8 configurations is a limited number where I can explain what the software does for you, so that you know what's happening, right? So what I do is I just consider 3 input conditions: developed, urban, and literate for the time being, and see how these 3 conditions combine to generate different configurations. Because these are 3 conditions, 2 raised to the power 3, 8 is the total set of combinations that we get. And what I have done is I have plotted all these 8 conditions, 8 configurations here. The first one is, remember, D negated, like lower value of developed, lower value of urbanized, and lower value of literate, 0, 0, 0. Then D is higher value, Z is again 0, and 1 is higher. So there are 8 different combinations that can be formed, and I've literally listed all those 8 combinations for you, similar to that colorful diagrams that we had initially at the start of this presentation. So what truth table would do is it will list all the configurations like this. You can do it yourself as well for a smaller version. For larger one, obviously you need the power of the computer. Now we have to decide, or this truth table would come up with case membership of each case in a particular configuration. And this was the question, Siv, you asked earlier, is which combination are stronger for a specific outcome. That we'll find out. First, we'll only find out if a case belongs to a configuration, and that we can only identify if its membership is more than 0.5. So first step the truth table does is to come up with the combination and then also calculate the consistency score. The consistency score is the measure that allocates each case to a given configuration, whether that configuration or whether this case belongs to that configuration or set of combinations. So that we find out through calculating a consistency score of, and if it's more than 0.5, then we can say this case is more in this set, is more in this condition. This is what we'll do right now. So smaller version just to explain the background working of the software, and then you can go and use the software for the complete version. Now, again, what you see, lots of information, but let me decipher it for you. Whatever I've been saying is actually here. What you see here are 18 cases and the 3 conditions that we wanted to initially examine to understand what the software would do. So each one has a calibrated score, each one has a calibrated score, each one has a calibrated score. And then what we did was we had 8 configurations or 8 combinations of conditions. 1, 2, 3, 4, 5, 6, 7, 8. There are a bit of typos here, but each would correspond to the combination that I showed to you in the previous slide. And because it's an AND operation here, logical AND. So this has been identified. There's some Boolean operations have happened here. We've got an outcome here, 0.01, 0.01, that comes when we perform logical operations on all these things. We'll see that all of these would have certain values here, but anything that's more than or that's 0.5 or more is highlighted. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So what we see here, any case that has a consistency score, this is what we call as a consistency score, more than 0.5, which I said to you in the previous slide, would belong to that configuration. So The first configuration, which is here, Greece belongs to this configuration, Italy belongs to this configuration, Portugal belongs to this configuration, Romania belongs to this configuration, and Spain belongs to this configuration. These 5 cases belong to this configuration. Then these 3 cases belong to these configuration. Then these cases also belong to this configuration. So what we get here, so out of the 8 configurations we have identified, 1, 2, 3, 4 do not have a case membership. These configurations are not supported by our empirical data. So they're gone, right? They're gone for our future analysis. We have to focus on configuration 1, 2, 3, and 4. These 4, the remaining 4 configurations with case membership would become part of our further analysis. Let's show that in another way. Not necessarily, Siv. We cannot say like that. No, we cannot. It's empirical based. So put simply, we had 8 possible sets of possibilities of different causal combinations. Out of these 8, our empirical data, which we calibrated, just supported 4 of these configurations. They would go out of our further analysis, because our next step is that based on these 4 empirically observed configurations, we want to identify some patterns that can help us generalize our findings. So we'll take the empirically observed configurations and use it for our analysis. One thing I want to add here, though, is that we need to have balance. If we do not have a balance, that's diversity. We should have some empirically observed configurations and some not empirically observed configurations. If we do not have diversity, that may cause us some trouble later on. But at this stage, probably I cannot rule on this thing whether it's good or bad. It's part of the process. Some of the configurations would be empirically observed, some of the configurations would not be empirically observed. Right? So, and this is the case memberships that I extracted from the previous slide. So you could simply map this through in your time, right? But I would go through further. Okay, now the same steps that we did, right? You could do that in an Excel sheet as well by following through the calculations. Easy. Yeah, exactly. Good point. Here, what we see is we've got this truth table that we have generated. You could just, whatever, like in this example, I did manually here, dragging over Excel calculations. If you go to the truth table, just one click, you'll have these values. But what these values mean, you need to have, the things that I explained that actually give you deeper understanding. You now know more. What are these numbers? What has been happening through this software? That's the whole purpose of. Otherwise, it's pretty simple. You click on it, you'll get the answers. And this is what our software output would look like. Exactly the same thing which I showed you in 3 slides. You wouldn't see the details numbering. What you'd see something like this, 5, 5, 5, 5, 3, 5, 5, 5, 3. 4 configurations are not observed. 4 empirically observed. 4 configurations are empirically observed. 5 cases belong to this one. 5 cases belong to this one. So on and so forth. Okay. Once we have constructed the truth table, which now I've shown you how to do it, I've shown you actually manually constructing a truth table through some Boolean operations, which you really don't have to do. And you just go to the software and double click, and you'll get all the answers. But now you know what it means for an configuration of not having empirical observations, right? And some configurations would have empirical observations, some would not have case memberships as well. Once we construct the truth table, the second step in this stage is to determine the frequency cutoffs and consistency cutoffs. Typo here. Consistency cutoffs and frequency cutoffs. What it means here, like here we just got 18 cases, and we saw that some of the cases were represented in multiple numbers in one configuration, 5, 5, 5, 3. We have a smaller sample, 18. So what this frequency cutoff says is that because you've got a large sample, let's say 280, 250, and you've got similar distribution like this, 5, 5, 5, 3. What you could do here is you can tell the software only keep the configuration with a minimum number of cases, 4, 3, 2, right? If you've got a large sample. In this case, because we do not have a large sample, just 18, we cannot say keep 5 and delete everybody, all other configurations. We'll keep the minimum number of cases to be included in analysis as 1. So we're just keeping empirically observed configurations, but we are keeping the lowest value, that's 1. The consistency cutoff 0 or more is universally, so that's what we call frequency. You just tell 1 for this particular case. And the second one is consistency cutoff, right? First, we learned that the consistency cutoff, if it's 0.5, that case is more in than out. We say it belongs, this case belongs to this configuration. If the consistency score is greater than or equal to 0.5. Now, if that consistency score is 0.8, if of course it's more than 0.5, but if that consistency score is 0.8 or above, that means that it has a strong contribution, almost always sufficient to deliver the focal outcome. If that configuration has consistency score of 0.8 or over, we say that it contributes to the focal outcome, 1. If it's less than 0.8, we say yes, 0.8 is the default. So when we are deciding whether this configuration is contributing to high performance or low performance, we have to differentiate in terms of 0.8 or less. If it's 0.8 or more, it's a strong performance. If it's less, it's low performance. And we code that in FSQCA as 1 or 0. 0.8 means, or above means 1. 0.0, less than 0.8 means 0. Let's see. And this is the calculation that the software does. You can do that manually in an Excel sheet as well, and you should get the same answers. And so this, and similar to consistency, there's another score called coverage, which is similar to R-square. Now, say your stats would come in here. R-square is similar to coverage, which is a separate measure, but the discussion that we have had so far surrounds or is around consistency. Coverage is another one that we'll talk later on. So if the consistency score we stipulate in the software as 0.8 or above, that means that any configuration with more than 0.8 would be 1. We'll talk about that when we go to that point, right? So let's focus on consistency, and then we'll go to coverage. Okay, same thing that I showed you 2 slides earlier. Then again, 5, 3, 5, 5, just a different combination. 0.98, 0.84, and the consistency that we have calculated, 0.98, 0.84, 0.44, anything less than 0.8 is 0. Anything less than or greater than 0.8 is 1. So this is 1. That means strong performance, causing that outcome, not causing that outcome, not causing that outcome. And these non-empirically observed configurations would now be deleted from further analysis. So our further analysis would take into account 1, 2, 3, and 4. Some of these would contribute to a strong outcome. Some of them would contribute to a low outcome, which we have identified as 0.8 as the threshold. And this is the value. So when you go to the dialog box in the software that will run shortly, you'll have either 1 or 0.8. 1 is for the frequency thing that I mentioned to you earlier, and 0.8 is the cutoff. More than that, we've got 1 strong outcome. Less than that, weak outcome. So that dichotomizes the performance variable. Okay, now I spent a lot of time, and if some of you think you're lost, okay, fine. So Andres, this question is for me.
Yes, the question is for you.
Yeah, go on.
No, we have a rich set of data with 200 firms in Sweden, where we have it's more categorical data. So it's so each of these values that you have mentioned there, development, urban, etc., they would be either 0 or 1. They would not be like 0.3 or 0.4. Would it work to use QCA then, or would it not work?
No, actually, Andres, park your question, right? Park your question.
Okay.
Park your question. The truth table says 1, 0, but it's based on the calibrated values. It's based on the fuzzy values.
Yeah.
Okay, so you should be able to do that. Absolutely, no problem. So let's park your question. When you run it through the break, we'll go to the breakout session. Then we'll talk about this particular question. Remind me then, right, when I come to your room. Okay.
Perfect. Thank you.
Thank you. Okay. Let's go to the 5 causal conditions of the illustrative problem. So I've given you the background now. The understanding of the Boolean things or Boolean operations that I explained that really helps in order to fully understand and generate insights. But after learning those, you just go to the software and you do that. So based on the fuzzy set, we develop a truth table, and when you just click on tuck, you'll have 32 configurations here, and based on the fuzzy inputs, and this would be the membership here, and then number of cases with 0.5 membership, all this one, and this would be the consistency score for them. So you will get this as your truth table. When you just click tuck, you'll get this value. So that would be your first step, C1, which you have done. Now instead of 8, you've got 32 configurations. And again, I'm repeating myself here, but it's just the same. The C2 is the same, which for the 3 or 5 would be the same. 3 conditions or 5 conditions would be the same. Because of a smaller sample size, we'll just take 1 because we want to keep any empirically observed observation. 0.8 means stronger performance. 1 less than 0.8 means weaker performance. That means 0. And this would be your truth table from the software, right? Exactly the same, but now we've got 5 conditions. And now what we've done is we have actually anything more than 0.8 is 1. Anything less than 0.8 is 0. But all these have some case membership. So we have used the dialog box to code 0.8 is the threshold for high performance and low performance, and also by stipulating the minimum frequency cutoff for this thing. So this we have done for 5 causes. Another thing that we haven't done which we must do is what we call as the necessary condition analysis. So the necessary condition analysis is done also in the same software, but a few clicks, not too difficult. You go to this screen here. When you run your software, you upload this data file. You would see those calibrated scores. What you do is you go to analyze When you click on truth table algorithm, you'll get the truth table algorithm that we did previously and that we did operation the previous slides, the step C. In step D, which is necessary analysis, instead of truth table algorithm, you go what we call as necessary condition analysis. And what we do here is outcome we identify, you click on this one, it will give you all the input, you click on survive because that's our outcome, and then add condition one by one, you add developed, you add urban, you add literate, you add industrial, you add stable, all 5 conditions. So first we perform necessary analysis and then we go to sufficiency analysis. So this is how we do the necessary analysis. And when you click OK, you'll get this output. And the output is simple. Outcome variable is survived, input variable is developed, urban, literate, industrial, stable. And the consistency score is what we'll use here. The consistency score tells us for necessary condition, that means that this condition has to be present almost always for the outcome to occur. So the conditions that are highlighted in red here for a consistency score of more than 0.90. The best practice is that if the consistency score during a necessary condition analysis, where you evaluate a single condition against its, the likelihood of its contributing to the outcome, if it's more than 0.90, that means it's a necessary condition. In other words, that means that it's almost always this condition would almost always be present for the survival of democracies to happen. So what we see here, literate and stable are the 2 conditions. If a democracy has to survive, it would nearly always have literate, whatever it was measured against, and the stability. These 2 conditions have to be present for the survival. We call that as necessary condition analysis. However, these necessary conditions have, their presence is one thing, whether they are sufficient to cause that thing is obtained through sufficiency analysis. So necessary presence is necessary, but actually would not lead. So that sufficiency would come into play here, and that we'll do in the next slide. So in order to do sufficiency analysis, we go back to our truth table, repeat the step that we did, and at the bottom of the truth table, we've got something called standard analysis. We click on standard analysis. When we click on standard analysis, this dialog box pops up. Just make sure that all this one is, let's keep to the default value and click OK. When you click OK, what would happen is we'll have our output, and our output or results would be in form of 3 solutions: complex solution, parsimonious solution, and intermediate solution. So complex solution is the one that relies solely on the empirical evidence, the empirically generated configurations. Parsimonious solution, because parsimonious solution is something that incorporates some additional configurations that were not part of the empirically observed, just to bring in the empirical evidence, which in case is not through our own data, but through some other outside, some external sources, so that we are able to take these findings and apply it to other contexts as well, other than the empirically observed configurations that are from our own data. That's what we call as parsimonious. Parsimonious solution actually helps us to generalize our finding beyond the empirically observed configurations. And the way we do, there's a specific phrase here, logical remainders. So the incorporation of logical remainders actually helps us, the generalizability of these results beyond the empirically observed configurations. That's the second type of solution. The last one is intermediate solution. This dialog box that you saw was actually asking us about some, plausibility, which input would contribute to which output. So that's our opportunity to inform the results through our theoretical and substantive knowledge to guide the incorporation of logical remainders. So intermediate solution is somewhere in between complex and parsimonious solution, which balances the empirically observed and also the logical remainders through the researcher's theoretical and substantive knowledge. So intermediate solution, parsimonious solution, complex solution, each corresponding to different requirements. Next thing is, and this is the solution that we've got coverage, we've got consistency, these are the two things, and this is complex solution, this is called parsimonious, intermediate. I wouldn't explain that here. Once you get the results yourself, then I'll explain those results here. Just to bring everything together, the interpretation of results, we've got three solutions. FIS 2011 came up with an approach that brings together these multiple solutions. And since then, the default way of explaining FSQCA results are after this FIS 2011's recommendation. He said that the FSQCA results must be explained through core conditions and peripheral conditions. A core condition, a causal condition, if it's present in both intermediate and parsimonious solution, we call it as a core condition. And if a condition is just present in the intermediate solution, we call that as peripheral condition. Core condition is strong, is very strong in terms of FSQCA result. It has got stronger causal effect than the peripheral condition. But together, the peripheral also explains, but if we have to put more emphasis, we put more emphasis on a causal condition that's present in both intermediate and parsimonious solution. That's what FIS suggested format is, bringing together parsimonious and intermediate solution to present the results in terms of core and peripheral conditions. What you see here is any FSQCA paper that you'll pick nowadays would have this representation. All causal conditions here, 1, 2, 3, 4, 5, 6, 7. High performance, low performance, so asymmetry. First run it through high performance and then run it through low performance. The bigger circles are the core conditions, which are present in both intermediate and parsimonious solution. Smaller circles are only present in intermediate solutions, one solution. The darker circles are presence of a peripheral condition, whereas the cross circle with cross is absence of a core condition. So absence of a core condition may also contribute to a stronger output. So we represent the results A in terms of core and peripheral conditions, and also in terms of presence of a condition and absence of a condition. Both are important. Presence and absence of a condition. That's what QCA brings in. And anything that's not present here shows indifference or do not care. It doesn't really matter whether that thing is there or not. What matters is if it's present or if it's absent, if it's core or if it's peripheral. So with this, let me summarize what we have achieved now. Is we have done the measures operationalization, we have done the calibration of conditions, we've defined the property space, done the necessary and sufficient condition, and also generated and interpreted results. Now what you should do is, I will share now a data file here, the Excel data file, and also there's a video link that I'll share now. Is you click on this video and it will guide you how to actually access the software to the website, download it, run it, and load the data file. It talks through all the steps, brief video. So you should watch that while doing it. It's a YouTube video that I just made today. What you need to do is I will divide you in breakout sessions. I think we should form groups, and you should be able to swap between different groups. Is that you should be able, or you should be forming groups with like-minded people. Like if you are a PhD student, probably a similar set of groups because you are the same frequency. Some accomplished researchers, like my colleagues here, they should form a separate group, right, and then talk to each other. And you can move between rooms as well. So you can go to this room, you can go to another room as well. See which room is you're more comfortable with. So at this stage, what I'm going to do now is first I'll make breakout groups where you will go, you'll have access to a CSV Excel file. You will be able to watch a video and then repeat the steps there. The idea is that you learn from each other. I'll also come to each group, but make most of this time and then be very comfortable of how to operationalize a QCA implementation. That's what the objective is. Any questions so far? Are we good to be formed in groups? Can we go and become part of different groups? Easy, good? Are you guys listening to me, right? Am I audible to you, right? Okay, I'll make groups now, and I'll just also share, while you're forming groups, I'll share everything, right? And I'll share, in the main chat video, I'll share the Excel file and I'll share the YouTube video. I think I'll first share the YouTube and first making you groups, and then, yep, let's make this. Okay, how many groups I need to make? Let me make 4-5 groups, and you can keep going between different groups, right? I make 5 groups. I allow attendees to switch groups as well. Okay. Okay, let me start. So there you go. Here is the link to the video now. Okay, there's the video. Okay.